So, let us talk in few slides about the natural disaster impact on human. Okay. So, a natural process when poses a threat to human life or property, it is termed as natural hazard, whereas a natural event that kills or injures large number of people or causes extensive damage to the property, it is called catastrophe. Many geological processes are potentially hazardous, for example, floods, earthquakes, tsunamis, cyclones, etc. Now, we need to understand the impact of natural disaster, which does not depend on the size of the event, but on number of people getting affected and the area vulnerable to such events. Okay. So, if less number of people are affected, it is not, these processes are not hazardous at all. Okay. So, example, an event in thinly populated area can hardly pose any major hazard. So, hence those events are not hazardous to us. Okay. But if you have more people which are exposed to such hazards, definitely that events are hazardous to us. Okay. Now, this is an example from the earthquake which occurred in on 15th July 2009 with a magnitude of 7.6. The magnitude, according to the magnitude, it was a severe event, but posed little threat because it happened in a region with few people or buildings. Okay. So, it was not very hazardous for that particular region. Okay. But other case, if you take, that is 2005 Muzaffarabad earthquake with similar magnitude 7.6 occurred in heavily populated region in Himalayas, killed around 80,000 people, and a much smaller earthquake with magnitude 7 in 2010 in Haiti, it killed almost like people more than 22 lakhs. Okay. So, this is one of the reason that we need to understand that where the event will occur and how many people are going to be affected by that. Okay. And accordingly, things have to be taken into consideration in terms of the mitigation and all that. Okay. So, this is just to show that over the time the loss of, that is the property and all that, okay, population has doubled almost, and the loss is becoming higher and higher day by day. This is 1995 Kobe, this is tsunami, and you are having the hurricane here. Okay. Now, this is the again the similar case. If we take on 2008 cyclone in Myanmar killed around 1.3 lakh people, okay, and mostly in the rural areas, because they were absolutely not prepared and no proper evacuation was been taken into consideration. Okay. Whereas, if you take in terms of there was a super typhoon, okay, which was categorized as category 5 storm, okay, passed directly over the northern islands south of Japan, but it resulted no deaths. Okay. Because very few people live in that area, whereas in terms of here Myanmar, it was not so severe cyclone or this storm which can be categorized as 5 under the category of 5, it killed many people. Again, example from US, the eruption of volcanic eruption which took place on Mount St. Helens in 1980 caused very few fatalities. Okay. Because many the population was very sparse in that area, but in case of Italy, this was a major event which took place. Okay. The volcanic eruption of Vesuvius, it resulted into killing of hundreds of thousands of people. Okay. So, the natural processes become hazardous only if they are going to affect more number of people. So, natural processes are hazardous if there is a change in the land use pattern. Okay. So, in the initial slides we were talking about that increase in population is one of the major factor why this processes are becoming hazardous. Okay. Because increase in population has exposed more number of people to such natural processes, and mostly in terms of we are moving more and more people are moving towards urban settlements. Okay. So, urbanization has also affected the climate to some part, and we have degraded the environment also. Okay. Because we are removing more and more number of trees, and that is what we are doing, deforestation, okay, which eventually can result into landslides in the hilly terrain and flooding in the plain areas. Okay. These plains are, we are talking about the alluvial plain, very much similar to what we have the Indo-Gangetic plains. Okay. And of course, the deforestation, what we are doing, utilization of agricultural field, and this will result into the flooding, more flooding in the urban cities. Okay. Because we lack in preparedness, we lack in planning also, and then disturbing the climate due to pollution and ecosystem. Okay. So, because of the human activities. So, these are the major reasons which are affecting the natural processes also. Okay. Mostly the climate, but the internal processes you cannot disturb at all. Okay. But more and more number of people are exposed to such hazards, and we are having these problems increasing day by day. Now, coming to the earthquake part. So, in particularly Asia Pacific region alone, if you take, okay, we have almost like 70% of the world's earthquake measuring 7 magnitude or more on the Richter scale at an average of 15 events per year. Okay. So, this is absolutely a very large number for this region. Okay. Then the countries like Japan, Philippines, India, Nepal, Afghanistan, Iran, and the Pacific Islands. Okay. These are the countries which are badly affected by earthquakes, and then as we have discussed couple of them, of course, they are the mega earthquakes from this region. And many of these countries in the region are located or are adjacent to the subduction zones. Okay. Or we can say the Pacific Ocean seismic zone or the Indian Ocean seismic zone, and both of them have triggered, like this one triggered 2011 Tohoku earthquake, and this one triggered 2004. So, we have these are the regions which are affected or vulnerable to the earthquakes, mega earthquakes. Okay. And for example, 50 to 60% of India is vulnerable to seismic activity of varying intensity, particularly the areas in Himalayas and along the Andaman regions. Okay. For example, if we consider the Indian subcontinent, we had earthquakes within the plate, and this is the example from Maharashtra 1993 Kilari earthquake, and we had 2001 Bhuj earthquake. Kilari claimed almost like 12,000 people, whereas Bhuj killed around 19 to 20,000 people. Okay. And Andaman, it was more than a lakh people were been killed. So, you can imagine that not a single area has been left out. Okay. So, we have Himalaya in the north, we have subduction zone in the east, and we have couple of events which are taking place within the plate. Okay. So, we have like 2001 and 1993. Now, if you look at the this information, it says the average number of earthquakes per year worldwide and a comparison of amount of energy they expand. Okay. So, only if you look at the magnitude which will be bothering us in terms of the damage will be above 5. Okay. So, these are the magnitudes. If such events occur, they bother us actually. Okay. So, it says that around the world between 5 to 6 almost like 2000 or around 200 events will occur every year. Okay. And if you go further up, 8 magnitude event will be around 3 of such type occurring around the world, and between 8 and 9 or above 9 will have the probability of occurrence of less than 1 events. Okay. So, we had this is Sumatra, and then we had again another one over here we can put, okay, that was 2011 Tohoku earthquake. So, this will keep on occurring. Okay. And I just want to mention a little bit here that with the advancement of the science and the understanding of the hazard, what people have done to save the property and life also. Okay. So, whenever there is an earthquake, there will be displacement which is coming right to the surface. Okay. So, if you are going to put any lifeline structure on this particular part, okay, you have to be extremely careful in having understanding that what will be the amount of displacement and what type of displacement will take place along this fault, okay, whether it is a thrust fault or it is a normal fault or it is a strike slip fault. Okay. So, this is extremely important. Along with that, of course, we are bothered about that what will be the magnitude and how deep the earthquake will occur. Okay. So, because along with the magnitude, the rupture areas will also vary. Okay. Of course, the peak ground acceleration will also vary depending on different magnitudes. Okay. So, this is an example which is which I feel is one of the best to understand and to know that how they were able to save the structure which was crossing the Denali fault. Now, this is an example from US where Pacific plate is subducting below the North American plate, and that has resulted into the formation of several active faults, and one of the active fault which they mapped and they knew was Denali active fault, okay, on which they studied, they carried out detailed study before putting an oil pipeline. Okay. So, I'll show what they did. Okay. So, this is what they found. Okay. So, how the Trans-Alaskan pipeline survived a big one they are talking about the event. Okay. So, this event was it took place on in 2002 November 3 with a magnitude of 7.9 on Denali fault. So, this is a Denali fault, and the proposal was that they wanted to put the pipeline, oil pipeline, and the pipeline was crossing this fault. So, initial plans were that the pipeline will go underground, but later on when they knew, of course, that there is a fault here. So, they had detailed discussions, and then the geologists, they took over the studies and they completed the detailed investigation, and then identified that this fault, if it ruptures in future, will have the displacement of almost like 20 feet. Okay. And then it will move right laterally. So, they had the motion that in which direction it will move and what will be the pattern of the movement. So, they finally planned that let us put the pipeline over the surface. So, they brought the pipeline on the surface, and with an understanding that how much movement it will this fault will result when there is a big earthquake, they constructed or they designed the pipeline accordingly. So, what they did was they put the pipeline on surface and made it flexible in such a way that it can move on this. These are the roller coaster on which they have put. Okay. So, this, and then the pipeline was quite flexible in that sense. Okay. So, earthquake occurred with magnitude 7.9. Okay. An investigation that revealed that the movement will be of around 20 feet. Okay. So, the pipelines are sitting on the roller coaster, and then you are having this flexibility which accommodate the displacement, and then it moved in 2002, the displacement was 18 feet. Okay. and the pipeline did not face any problem. What happened was something like this. Okay. So, it was so flexible that it accommodated the displacement. So, Denali fault is over here. Okay. So, in that case, that is what the example I was talking about, that if you understand the hazard and where it will occur and what will be the magnitude of that hazard, whether it will be severe or it will be less severe or it will be extremely severe, then you can plan the things accordingly. Okay. So, this is one of the best example which we have which saved the pipeline. Okay. Similarly, you can do about the structures and all that. So, why one needs to understand the natural hazard, how to study, what one should do. The study of natural hazard is a part of environmental geology. Okay. So, in a broader sense, you can classify or categorize this as environmental geology part. Okay. Because natural hazards are catastrophic events which have direct impact on human lives and causes deaths and damage. So, if event occurs, then it takes long time for recovery and rehabilitation. Okay. One can study the processes and identify the potentiality of particular hazard in particular area. So, for example, we were talking about Denali fault. So, we knew the location, okay, and we knew about the particular hazard, okay, and the potentiality also. So, accordingly we designed the structure. So, the another part, and then if this information is made available to the people, then you can avoid and reduce the risk factor. Now, this is a very nice correlation which has been done, okay, between the plate tectonics and the earthquakes and other hazards. Okay. If you consider the plate motions which we discussed in the previous course, okay, plate tectonics or mountain building activity will cause earthquakes, will cause tsunamis also along the subduction zones, and even it can result into the volcanic eruption. Okay. As well as the volcanic eruptions can also trigger tsunamis, and volcanic eruptions can also result landslides. So, if the volcanic eruption is taking place close to the ocean, okay, then it can result into the landslide. And another part which I would mention here, there is one more slide which will be talking about the type of landslide or mud flow which can be resulted because of the volcanic eruption. Suppose a volcanic cone has been covered by snow here, okay, and if the eruption takes place, okay, then it will result into the snow melt, and that snow melt will cause the mud flow, and that is the type of mass movement. Okay. And further, this mountain building activity, because of the ongoing deformation in the hilly areas, will result into landslide. Earthquakes can also result into landslides, okay, because the strong ground shaking will result into the loss of shear strength of the slope material, which can trigger the landslide. Then landslide can trigger tsunamis. So, in ocean, if you are having submarine landslide, large chunk of mass has been moved into the ocean, and the ocean water, the water column will be disturbed. So, this can also trigger tsunami here. Then mountain building activity will also affect the weather and climate. So, best example is that we had the plate tectonic, because of the plate tectonic movements and the collision, the Himalayas were formed, that is mountains were formed, and we had different weathers in the region. Okay. So, this is also interconnected or interrelated, okay. And then volcanic eruptions can also cause the change in the climate and weather, okay. Because if we are having continuous volcanic eruption, lot of ash and carbon dioxide will be put in the air, and which can result or affect the weather and climate, okay. And weather and climate in turn will result into hurricanes, or you can say storms or cyclones, and then can result also into the flooding events, okay. And if you are having flooding, it can result into landslides, and also the weather, if you are having extreme weathers, you will have faced the landslide. So, please carefully go through this chart which explains the interaction amongst the natural hazards. Okay. So, in short I would say that this all processes are interconnected, okay, and will affect one another if there are slight changes taking place. Okay. So, then an example of 2014 earthquake in China, the magnitude was not very large, it was a moderate magnitude earthquake of 6.1. It resulted into severe damage, but not many people were been killed, around 398 people were been killed here. And then this is a pattern of damage which was experienced in Bhuj. We had lateral spread, this is typical of lateral spread we are having and can be categorized at, so we can say this is an lateral spread. Now, this took place on a very gentle sloping surface and the land slipped in this direction. So, this is a part of we can categorize it a landslide or landslip. Okay. Then we are having the liquefaction, this is what I was talking about, and this is very typical of the liquefied sand coming onto the surface through this vent here, and this has been poured on this side. Okay. Very much similar to the volcanic eruption. Okay. But this is what we call as sand blows. Okay. And this phenomena is related to liquefaction caused by strong seismic shaking. Then we have this example again is from the area close to the coastal zones and from Gandhidham in Kutch, where you can see this black spots. Okay, these are all the sand blows which resulted into the pouring out of liquefied sand. Then of course, along with that we face damage in Bhuj area and around the Bhuj. Severe damage was been experienced. This is an example from 1964 Nigeta earthquake. The building were toppled down because of the loss of shear strength of the underground material. So, this is again an example of the liquefaction. Okay. So, the land lost the shear strength or the surface lost the shear strength because of strong seismic shaking, which was resulted by liquefaction. This is a liquefaction from New Zealand, okay, Christchurch earthquake. A lot of sand came on the surface and along with the water. Okay. Then coming to another part, the landslides are very common in hilly and mountainous part of the Asia Pacific region, occur frequently in India, China, Nepal, Thailand and Philippines. Okay. Now, landslides are aggravated due to the influence of topography, okay, or we can also say that to some extent by human activities such as deforestation, cultivation and construction, which destabilizes the fragile slope. Then as a result, if you take the combined effect or the action of natural and human induced factor, as many as greater than 12,000 landslides occurs in India and Nepal every year. Okay. So, landslide in Himalaya are also caused along the active faults, okay, because active faults are the areas where you will have the recent deformation or ongoing deformation because of the ongoing plate movements. Okay. And this portion or the region will have more fragile material or sheared material in the which can result into the liquefaction if they are subjected to heavy rains. Okay. These are the areas which shows the prominent regions of the landslides. So, mostly we face the landslide in the hilly terrain. Apart from this, of course, we also have the regions which are facing the landslides in this area, okay, because of the heavy rain and all that. So, highly affected areas are been shown with the darker green colors and marginally affected areas by this one. So, mostly if you consider this, we have the hilly terrain in this region, okay. And of course, along with that we have the rainfall is also more in that area. So, these are few of landslides which have been listed here, which occurred in recent years. So, disastrous landslide in India. This is from Nepal. This is from Pune in 2014, another again from Nepal in 2014. This what I was talking about, that if you are having an volcanic cone covered by snow, so during an eruption it may result into the mud flow, and this mud flow type has been termed as lahar flows. Okay. So, this is an example from Colombia, where the snow melt because of the volcanic eruption resulted into mud flow, lahar flows in 1985. Then coming to the floods are most common and more frequent, okay, because these are again seasonal, and we have every season in most of the areas where we have inadequate drainage facilities, and more number of people have occupied the floodplain areas, have experienced the floods. Okay. So, it includes seasonal floods, flash floods, urban floods due to inadequate drainage facilities, and floods associated with tidal events induced by typhoons, cyclones in the coastal areas. Okay. Mostly in the when we have the monsoon, extreme monsoons, we have these problems. Okay. So, from June to September each year, monsoon in southern Asia will result into most of the areas are flooded because of the inadequate drainage. Okay. If you are having a proper drainage and facilities and all that, so you may have less problems in terms of that. Okay. So, rains are crucial of course for the agricultural, but at the same time they pose hazard to the crops, homes and people. Okay. So, flood often submerge the fields, destroy buildings and contaminate drinking water. So, not only it will result into the submergence of the field, but in other terms it will also contaminate the drinking waters also. Okay. So, groundwater is also getting contaminated. This is just to show that what is the pattern of rainfall we received or we keep receiving every year in different part of India. So, the dark blue color, which shows that these regions are receiving rainfall almost like around 400 centimeter per year. Okay. So, you are having these regions, okay, whereas very scanty rainfall is somewhere over here. Now, based on this, these regions have been classified into different climatic zones. Okay. So, these are what they have termed this as an arid. So, arid is this one here, you have this area arid to semi arid we are having, okay, and this regions are the areas where we have very large amount of rainfall. So, humid to subhumid or so. Okay. So, nowadays we are even facing the areas which are considered to be arid and semi arid, like Rajasthan and Kutch regions. They have also experienced floods in recent years. Okay. Other than that, these regions are always experiencing floods like Bihar and Uttar Pradesh. There is an example from 2006 flood in Tapti, but the most important part which we learned from this area was this is from Gujarat. This is the city of Surat, which was affected by severe flood in 2006, and then flood was related to the heavy rainfall in the upstream of Tapti river. But this area, that is Surat city, did not have much of rainfall. Okay. So, this was because of the heavy rain in the upstream and opening up of the tidal opening up of the dam reservoir, okay, resulted in the flooding in the downstream region. Okay. So, this is another, whether this should be called as an man-made hazard or this should be termed as a natural hazard. This is another question here. Okay. So, I will stop here. Thank you so much.